Welcome to Geometry. Today's video is going to take a look at spheres. We'll start with some vocabulary and definitions. A sphere is the locus of points in space that are a given distance from a point, the center of the sphere, versus a circle is the locus of points that are coplanar, a given distance from a point. The radius of a sphere is a segment from the center to any point on the sphere, so that's going to be the pink line segment. The chord of the sphere is a segment whose endpoints are on the sphere, the green line segment down below. A diameter of a sphere is the chord that contains the center of a sphere, so that's this line segment in the middle. And a tangent is a line segment chord array that intersects the sphere in exactly one point. And you can see that above as the red line. Of all shapes, a sphere has the smallest surface area for its volume. Little trivia. When a plane intersects a sphere, the result is either a point or a circle. If the plane goes through the center of the sphere, the intersection is called a great circle. Examples of a great circle. Well, even though the Earth is not a perfect sphere, we can think of the equator as a great circle. We can think of the prime meridian with its anti-meridian, and any slice through a sphere that is the largest slice through a sphere would be a great circle. The great circle is also very useful to pilots when they're trying to find the shortest distance between two locations. The shortest distance between points on any surface is called a geodesic. In a plane, a straight line is a geodesic. On a sphere, a great circle is a geodesic. The surface area of a sphere is 4 times the area of the largest cross-sectional circle, called the great circle. So it's 4 pi r squared, which can also be written pi d squared. We're going to derive the formula for finding the volume of a sphere, and to do so, imagine the interior of the sphere is approximated by n pyramids, each with a base area, uppercase V, and a height of r. So the radius extends out, that's the height of my pyramid, and then the base of that pyramid is uppercase B. And we know from our volume of a pyramid, it's 1/3 the area of the base times the height. So the volume of the sphere would be approximately equal to n of those pyramids. If I just regroup that little formula, I get 1/3 nb's times r. Well, nb's is basically the surface area of that sphere. So now I can plug in 4 pi r squared for nb's, and if I simplify, I get 4/3 pi r cubed. I'm also going to show you a quick visual demonstration of the volume of a sphere. It says a sphere that is completely filled with water. And so they emptied the sphere into a cylinder with the same radius and the same height. And what they got was 2/3 the volume of the cylinder. Now, if we plug in the formula for volume of a cylinder, pi r squared h, and simplify, the height is twice the radius. And if I simplify, I get 4/3 pi r cubed. So another way to visualize and then use that information to derive the formula for the volume of a sphere. We're going to practice more with volume of a sphere and then volume of mixed solids going forward. Have a great day.